All right, 35. So this is a minimizing problem, which I think we kind of have maybe looked at before with like the boxes and stuff when we were trying to find like the maximum volume, stuff like that. Kind of like that, just a little bit different in how we do them now. So consider all rectangles with an area of 182 feet. Let x be the length of one side of such a rectangle. Express the perimeter as a function of x. So basically we've got information that is important. The area is 182 feet squared. We have a rectangle. Now we know that the length of one side is x. That was given to us. So that's a known. Now, based on that, okay, or let me rephrase. What generically is the area of a rectangle?
Length times width.
Length times width. So in general, area equals length times width. In this case though, width is x. So area is equal to Lx. So now I need to know what my length is. So how do I solve for length?
A divided by L equals X.
X.
I'm solving for L, but A divided by X equals L.
Oh, that's fine.
Okay, which is then 182 divided by X. So that means that this side over here I've now solved for is 182 divided by X. And obviously I don't know what X is yet. Now, what do you know generically about the perimeter of a rectangle?
2 length plus 2 width.
Yep. So the perimeter is equal to 2L plus 2W. Now, in this case, W is X and L is 182 over X. So I'm going to replace that. So that means for the first part it says to express the perimeter as a function of x. So that means P equals 364 divided by x plus 2x is part A of this problem. Okay, so perimeter as a function of x. Now, it says, for part B, find the dimensions of the rectangle that has the least perimeter. What is the least perimeter? So, basically, I can graph this function. Okay, so I'm going to put it in graph, and I'm going to find the minimum. And that's going to help me to solve that. So, and I would input this as a fraction as, like, make sure, well, anyway, just make sure you type it in correctly. But I do it as a fraction, so it's easier to deal with. Where did it go? Zoom.
I think you might have to like
6.
make it
Nope.
fit.
Zoom. Where is fit? 0. Now, what do we know that x can't be?
0.
Well, it can't be 0, but it also can't be what? Because it's a side length.
Negative.
Right, can be negative. So I need to use the positive one. Let me see. So
Did you get anything to come up on your graph?
you have to do zoom fit, zoom
Yeah.
0.
if you press trace, then you'll see it's a really big number.
Hold on a second. Because I'm trying to get this to... Hold on a second. What? I now remember why I don't normally do this part of this problem.
It's kind of confusing.
It is, and I don't think you would have just gotten to this answer on your own either. Actually, maybe you would have. Hit or do second trace and do minimum. For your left bound, do it up on the like left hand side of that graph that's like up in the air. Do it on that part. And then arrow over to like X is like 14 or 15.
It won't let me get up to that part of the graph. I have to do the other one first.
You just have to arrow over and it'll do it. Just keep arrowing to the right and it'll come up.
There it is.
Basically arrow over till you get to like, so your left bound is going to be at like X is like 1 or something like that. And then your right bound, go till your X is like 15 or something.
It lets me go to 10.
Keep arrowing.
Okay.
It'll do it eventually. It just needs a second. It has to like catch up because I would keep going and it would just like stop and then it would.
So it's like the minimum, is it finding that by like adding the x and the y together?
The minimum is the X value.
How much do you want us to round it up to? Just 2?
Yeah. So I got for part B basically that the minimum occurs when X is equal to 13.49 and Y is 53.96 basically. That's where the minimum occurs. Apparently this is the perimeter value. The Y value is the perimeter, apparently. So if you did, and this is your side length for width, but there's some indication that if you did, oh, I know why. Basically, that's the smallest it can be to give you that, and this will produce a square because a square is the smallest rectangle you can get.
I understand.
Yeah, it's weird. I wouldn't, if I were to ask you, I would be asking you for part A on a quiz or something. I was thinking this was going to come out differently than it did, but this would produce a square, which is what would give you the smallest amount that you could have. Basically, if you squared 13.49, then you'd get the area of that, which would be the smallest anyways. Which 13.49 squared gives you 182, rounded, obviously. Okay. I'm just gonna have to do 37 tomorrow because I'm gonna have to leave before. But it's basically a volume problem of a cylinder. So we'll just have to look at that tomorrow. But if you haven't finished the problems, that's what you can do for the rest of the time. And then if you have a question for him, you're welcome to do that.